it's a lot of information, I understand that. I know it's a lot of unfamiliar information, but let's keep working on it, okay? First one, dilution series. We use milk. It could be apple juice, it could be a Coca-Cola, it could be, say, anything you wanted to check, green beans, blend it up, it could be anything you want to check. Now, first I want to say, what is the goal? We run this dilution series, we count the colonies, and I've had people ask, well, why do we do it? Why do we do it?
Count the bacteria.
The number of organisms per mil in the original sample. That's why we do this. That's why we go through all this series of patterns. Now, what you have to learn, these are the most basic dilutions you can do. They can get really involved. You can start doing half mil to 4.5, which is the same thing as a 1 to 10, but you don't have to know that. It is always amount added over total volume. Amount added over total volume. You need to keep two lines clear in your mind. One is the line of what is the actual dilution I'm doing as I'm going from here to here to here. Second line of knowledge, what is the cumulative, actually multiplicative dilution in the actual container via test tube or milk dilution model. So to run dilution, 1 ml placed into 99 mils, amount added over total volume. So that's 1 ml over 100, or 1 over 100, which is a 10 to the minus 2. That's the first dilution we've done in this example. This is a pattern. I could have gone 1 ml into a 9 ml test tube, or I could have dropped and done a 99 ml over here, so learn what they are, right? Then I took 1 ml and put it into 9 mls from the sample. I have decreased the organisms now, haven't I? Thinking through it logically. Thinking through it logically can help you understand. Well, 1 over 10 is another 1 to 10 dilution. So from here to here is actually a 1 to 10 that you have processed. You take 1 mil into another 9 mil, that's another 1 to 10 or 10 to the minus 1. That is what you're doing. Now, when you're talking about what is in the test tubes or the bottles, that adds together. Well, this stays the same because it's the first one. So 10 to the minus 2 stays 10 to the minus 2. Whenever you play here, it's going to be essentially coming from the 10 to the minus 2 dilution. This 1 mil plated stays the same. That's just the way it's done. But here, you have a 1 to 100, a 1 to 10. You're going to have to realize that 1 over 100 times 1 over 1, well, 1 over 110, it's going to be 1 over 1,000, which is 10 to the minus 3. See how you add the zeros or multiply actually? This becomes a 10 to the minus 3. You plate 1 mil, still 10 to the minus 3 on that plate. If you plate another 1 to 10, remember you're decreasing the organisms, is 1 over 100 times 1 to 10 times 1 to 10, or add zeros, is 10 to the minus 4. Okay, 10 to the minus 4 in this last test tube. Yeah, that's the dilution factor. Plate 1 mil stays the same on the plate. If you plate a tenth of a mil, which is 10 times less than 1, what is going to increase on your plate? Your dilution. You might have fewer organisms. So if you're going to talk about the plates, this matches 10 to the minus 2, 10 to the minus 3, still matches 10 to the minus 4. What is that?
10 to the minus 4.
5.
10 to the minus 5.
Oh, okay.
10 to the minus 5, because you're plating less. Okay, 10 to the minus 5. Now, the next step is you have to be able to look at 4, 5, 6 plates, decide which ones to count. You don't count all plates from every dilution. You only count the plate that appears to be what in what window? 25 to 250 or 30 to 300. Probably not showing at 30 to 300, but you're going to see both or something around there everywhere you go. So I'm going to say either one's acceptable to me. CFUs is a scientific term for colony forming unit in a colony. That comes from the fact that if you're doing mycobacterial, they're going to keep clustered together, but they'll still be pure and they come up with you. Okay, this is 2 numbers to count. Don't try to count something that has hundreds and hundreds and hundreds of colonies all in the plate. You can't do it. We're going to say that this one has 800 and What do you really need to do? 1, 2, 3, 4.
Scientific notation.
Scientific notation.
10 to the negative 5. Oh,
Keep
5.
reading this. Excuse me. What is this number? What have you discovered?
The original.
The number of organisms per meal back in the original sample. Tells you how many organisms, how contaminated, what you need to think about in regards to the next step you're going to do, whether it's drink it, don't drink it, or sell it. Now, I've been asked several things. I've been asked, do we have to count the plates? Yes, you'll probably have to count the plate. I've been asked, do we have to figure out the dilutions? I said, yes, you'll have to be able to figure out the dilutions. I've been asked, do we have to back calculate? Yes, you do have to back calculate. This is a midterm, okay? You need to know the information. I like y'all, you're great, you're wonderful, but just learn. Learning is our goal, okay? That is an example. It can change. I can change the dilutions. I can change the cells in here. I will take a window. If you say something like, I don't know, 8.2 times 10 to the 5th, you'll still get credit. I figure, you're doing your best. But if you say 8.2 times 10 to the 3rd, what's wrong?
You got your zeros wrong.
You went from the wrong dilution. Small points. How to calculate. How to calculate. Now, when we do this, obviously these are going to be maybe 1 or 2 problems each. So don't focus 80% of your studying on this and forget all the slides, all the media, all the lab equipment like the Spec 20 and the stains, etc. Because obviously I can't do 20 questions on this and 20 questions on that. Alright? So the probably 1, 2, 3, or 4 questions max for each, not more than that. Media calculations, patterns, learning patterns. How many meals in each test tube? I said 3. How many per student? In this case, 2. Now, these can change. So you need 6 meals per student. But you have a class. You're not just making it for one person. So we say 25 people, 6 times 25, you get 150 meals. That's a nice number. What does it represent? It's the volume that you're going to have. In this case, distilled water you're going to add to power 2. Distilled water you're going to add to power 2. So that's the volumes. Now you want to find out how much powder to add. This is the answer, by the way. Somebody asked me, where did I get that number from? Was it on the bottle? No, this number's not on the bottle. Okay? This number's on the bottle. When I brought a bottle up here to help you out, it will tell you how many grams to add per liter. You should know your metric. A liter is equal to what?
1,000 mils.
1,000 meals. 1,000 meals. I'm sorry, but during the midterm, I will not tell you how to translate a liter. Come up to me and say, what is a liter equal to? I say, I'm sorry, you need to know that. But I've told you now, okay? So I'm not just leaving you to drift. Okay, as 30 is to 1,000, you want to know how much, because you don't know this, to add to 150. Cross multiply. 1,000x, which is your unknown variable, is equal to 30 times 150 to the math. And it becomes 4.5 grams that you add into this to mix up, to distribute, to have enough of that medium for the whole class. Okay? A little bit different on the plates. I will not make you memorize it, but basically it's 20 mils per plate. I'm going to give it to you in questions. You need to do the similar pattern. You need 4 plates per student. Well, you know how much you